Hello guys, we are back with our next lecture. In this lecture, let us start our discussion with respect to finite automata, guys. Okay. So before going in detail with respect to finite automata definition and all those things, and then we are discussing about deterministic finite automata, non-deterministic finite automata, non-deterministic automata with epsilon and mire. So before going into all of these things, so first let us take a small example with respect to deterministic finite automata, and then we'll be understanding all the concepts about deterministic finite automata, and later on we'll be moving step by step to each other, guys. Okay, so in this lecture we'll be discussing in detail about deterministic finite automata, and to be clear, I want to take first an example, guys, and I will explain everything in the example. Then we'll be coming back to the theory and understanding it, how exactly do they mean in theory. Okay, yes, so let us first take a small example, guys. Okay, so I think the best example will be a string starting with b. Okay, so I think everyone remembers, right? So we discussed about language and all those things, right? Yes. Okay, so assume that the given symbols which we are going to use are a and b, and this is our particular alphabets, guys. So these are our alphabets to be used in our particular language, right? Yes. So once we have decided what are the alphabets, then our next goal is what are all combination strings, guys. So there could be various combinations of string, right, with respect to a b. Okay, but our goal language is in this way. So it might be single b, it might be ba, it might be b double a, it might be b a b, or it might be b a, it might be b b b, it might be b a b. So in that way. So the only restriction which I am saying is starting with the b, guys. Okay. So when I am clearly saying that it should start with b, what is my only condition here, guys? I don't know anything. It should start with a. That's it, right? Yes. So basically, please concentrate for some time, guys. You will get a clear idea like what exactly I am trying to draw, and you will understand that how to draw it also. The only reason why I am directly going through an example is because if I start teaching you in theoretical way, you will think that what is this in that way. So that is the reason why if we spend some time in designing a particular finite automata with respect to determinism, it will be really easy for us, right, guys? Okay, yes. So the diagram which we are going to draw is a DFA, guys. So the full form for DFA is nothing but deterministic finite automata. Okay, so I'll be explaining you what exactly do it mean by determinism also, so don't worry. Okay, yes. So what is our goal, guys? So it should start with the b. Okay, so in our whole list, what is the minimum string, guys? I think b is the minimum string, right? Yes. So let us start from a state q0. So basically this q0 is what, guys? It is a state, and wherever you want to start, you will indicate with an arrow. Okay, so now from a q0, so this is alphabet, assuming that this is a symbol, assuming that way. So this is a 1, like that, 1 2 3. So that is just as the state number which I am giving. In traditionally we start with q0. Okay, yes. So once I find b, so now assume that you are at a q0, guys. Okay, so you are at a q0, and our goal is to find this b, ba, baa, these strings. So now what is our goal? So if it is starting with b, you are going to use this. So now our only condition here is it should start with b. If it starts with a, I don't know what to do, but if it starts with b, I'm going to accept it. That's it. So now what is the diagram for accepting, guys? So you will draw double circle. So in simple words, this indicates a start symbol. This indicates a final state. So it means it is it has been reached to the final state, and the string has been accepted. So if your string is at the final state, it is accepted, guys. Okay, yes. So now observe. So if it is a single b, we are accepting, but we want to accept ba also. Okay, so now once I am here, so now if a comes, what I should do, guys? I can loop here, right? So if a b, how many a's comes also no issue. But suddenly if b comes, what I should do? B is also okay, right? Because the only condition is starting with b. So now for b also, let us keep a loop. So indirectly now think, guys. So now assume that this guy came and he started with 1b. Then he started with 1a, 1b. So whatever he might roam here, at the end he will be there only, right? So from here he's not going to some other state. So indirectly, once it started with once it started with b, you reach the final state, that's it. So whatever you do now, whatever string you get, you're just roaming there only. So it's indirectly you're not doing nothing, right? Yes. But what if in the initial stages only if you got a, what you will do? means indirectly if it is A, your answer is wrong, right? So now you can stop there itself. So that is the reason why. So this state is nothing but a dead state, guys. So Q2 will be having a self loop for A as well as a self loop for B. Okay, yes. So now once you get this, so you can go here, but from here this is not a final state, right? So from here you can never come here, right? So that is the reason why this state is called as a dead state, guys. Okay, guys, the terms in the first video, it might be a bit confusing, but I'm 100% sure that we will be designing over 50 to 100 of these diagrams. So you will be addicted for this type of terminology, guys. So don't at all worry about these things. Okay, yes. So now I told you, so this is nothing but the finite automata, guys. So now your question will be, okay, so then what is this determinism? So you told you will explain me later on. So determinism here means, if I am at Q node, if I say my input is A, I can 100% go here, right? So is there any confusion that if A is there, I should go here or here? No, right? So that is nothing but a deterministic finite automata. So we are having one more version, that is a non-deterministic finite automata. So in that, for a single input, like from here, for A you can go here as well as you can go for A for there also. So those type of things will be there. So that is a non-deterministic finite automata. Got it? Yes. So anyway, I'm not going in depth of it. Okay. Yes. Because that topic is for another lectures, right? Yes. So now we are mainly concentrating on a DFA, that is a deterministic finite automata. So now I think everyone got a clear idea with respect to this, right? Yes. So now let us go through some basic terminology with respect to DFA, guys. So DFA is represented with the 5 different items. Okay. So the first item is, so if you observe this diagram, so what are available in this diagram, guys? So we are having some states, Q0, Q1 and Q2. So these are nothing but our states. So we represent it with the Q, guys. Okay. And similarly, this particular thing is also having a alphabets, right? So sigma is nothing but A and B. Okay, and it is also having some transactions, right? Okay, some transitions, to be clear, right? Yes. So basically from Q node, if I give B, I will go to Q1. From Q node, if I give A, I will go to Q2. So this is the way how we represent it, guys. So from Q2, if I get A, I will go to Q2. From Q2, if I get B, I will go to Q2. From Q1, if I get A, I will go to Q1. From Q1, if I get B, I will go to Q1. So just this diagram only, I represented in terms of strings, right? Yes. So this symbol is used for the writing these transition functions, guys. So in simple words, this transition function, if you observe, so it is nothing but one value of Q, comma, one value of this gives another Q, right? So you can write it in this way, right? So Q into sigma is equals to Q, or implies Q. Got it? Yes. So that is the representation for it. And after that, we are having a start symbol, right? So here I represented with this arrow. So Q0 is the start symbol, and we are also having the final symbol. So that is a Q1. So these are the 5 symbols which are used to represent any DFA, guys. Got it? Yes. So now I hope everyone got at least some basic idea with respect to the diagram and representation, right? Yes. So now let us go to the theoretical understanding. So now you will get a clarity on each and everything which we are discussing, guys. Okay. Yes. So basically, first of all, what is automata? So I told you finite automata. So first let us learn this automata. So automata is defined as a system where energy, material and information are transformed and used for performing some function without a direct practice of man. So here, if I design this machine and if I give it to computer and if I say that whether BAB is accepted or not, it can easily do it and it will say the answer, right? So do I need to solve that? No, computer will solve it. So that is the thing which we want to do with respect to automata. So in simple words, automata is almost similar to automation, right? Yes. So automation. So it's going to perform on itself based on some steps, right? Yes. So automatic machine tools, automatic packing machine and printer, etc. Okay. Yes. So those are some examples of automatas. Okay. So now moving on to finite automata. A finite automata is a model that has an infinite set of states represented in a figure with the circles. So this is nothing but that, guys. Okay. And control move from one state to another state using, okay, in response to external input. So basically if B comes, I will go here. If A comes, I will go here. So in that way. Okay, so now there are two types of machines, guys. So the first machine will not give any output. So here, did I get any output outside, guys? No, right? I am saying whether my string is accepted or not, that's it. So there is no output concept here. But there are few machines which can even give output, guys. So now we are discussing this part. So now we are in this first part, deterministic finite automata. So after around 5 to 10 lectures, we'll be moving on to non-deterministic part. After that, around 2-3 lectures, we'll be moving on to with epsilon. After that, around 2-3 lectures, we move on to Mure. After that, Mealy. So those are some other machines which we'll be discussing. So once all these things are done, then we'll be moving on to the next stage. Okay? Yes. Okay. Okay, so shall I explain you this now? Okay, so basically the goal machine. So what machine do we want to create, guys? So if you recall, I gave you some introduction about non-deterministic one, right? Yes. So in a non-deterministic, what is the issue, guys? So if I am at Q node and if the computer thinks that if A comes, I can go to Q1 and Q2, then how come computer can decide, guys? So that's a huge confusion to computer, and I clearly told that computer works only on unambiguous information. So this is an ambiguous information, right? So if both of them are saying A, so that is the reason why even we create any of these non-deterministic machines, we are going to convert them into finite deterministic automata, guys. So any machine you design, you are at the end of the day, you will convert it into deterministic finite automata. Got it? Yes. And the minimum version. So basically, this is the same question. This the same thing can be drawn with the bigger circuits also, right? Yes. So always we try to have minimum. So that's not mandatory, but it's good, right? If it is minimum, yes. Okay. So now moving on to the tuples. So these are the 5 tuples which I discussed, right? So this is what it is written in theoretical approach. So deterministic finite automata is defined as a 5 tuples: Q, sigma, delta, S and final. So Q indicates a finite and non-empty set of states. So that's what we have written here. Similarly, sigma indicates the alphabets, right? So sigma is a finite non-empty set of a finite input alphabets, right? Yes. Moving on to S. So if you recall, what is S, guys? What did we write? So we wrote S is nothing but, sigma is nothing but a transitions, right? So is a transition function delta such that Q cross sigma equal to Q. Yes, and moving on to S is nothing but a start symbol or initial state. So S will belong to Q. Similarly, F is nothing but a final state. Got it? Yes. So these are the 5 tuples with respect to deterministic finite automata. Okay. So here I took a small example, guys. Okay. Yes. Okay. So for us, this is the example. Okay. Yes. So now few important points that you should remember with respect to deterministic finite automata. So those points are, for any state we should have all possible combinations. Like if a sigma has a comma b, then every state should have transitions from both. Okay, so if you recall, when I am discussing initially about this finite automata, then I told that if we want the transition from Q node, and if I am checking only the values of b, so this is the final state. So A and B will be coming in the loop, right? I can represent in this way also. In a single loop also you can represent A and B. Okay. Yes. So what is this block of machine doing, guys? So it is also recognizing the starting with the B only, right? Yes. But here the only issue is what if A comes? Okay, so why is there a confusion? Because I did not even specify what happens if A comes, right? So these type of things should not be there, guys. So we should define each and every symbol at each and every state. Okay, so for Q1 I represented A comma B. Similarly for Q node also I should represent A comma B. So what will be the A thing? So you will go to Q2 state. So this Q2 state is a dead state. So again for Q2 also I should represent A and B. So I will roam it here itself. So indirectly, whatever starts with A, all those things will come here, right? Yes, all the things which start with B will come here. Got it? Yes. So that's a quite interesting one, right? Yes. Okay. And there is no multiple paths. So basically, if A comes, I will go sometimes here, I will go sometimes there. Those kind of things are not there because it is a deterministic one. Okay. And initial state is a maximum one. Okay. And to be clear, you can never have a diagram with the 2 initial states, guys. I will start from here, I will start from here. So that's a huge confusion. Okay. Moving on to final state, and final state should be minimum 1 and maximum. All states could also be final. So every state also you can make it into final if you want. Okay. Yes. So now I hope everyone got a clear idea, right? Yes. Okay. Yes. So basically how finite automata works in reality is, so this is our string, guys. So whenever we want to test these things, we are going to input a string, right? So let us try to input a string. So let us input a BAA. So if I am at Q node, once a B comes, I will come here. Once A comes, I will roam here once. And one more A, I will roam here once. So indirectly BAA, I am at the final state. So the string is accepted, right? Yes. So in the same way, how it works in CPU is, so in CPU we are going to have this finite control, guys. So as you read the string, so this moves step by step. So instead of drawing the diagrams in this way, you are going to have in this way, guys. Okay, yes. So that's just for your understanding, guys. That's it. Okay, yes. Okay. So deterministic refers to the uniqueness of computation application. So this finite automata is applied, or the major application of lexical analysis, guys. So to be clear, this is the one of the most important topic or important stage in compiler, guys. Okay, yes. Okay, so now whatever we have drawn here, so let us try for this also. Okay, so this is our transition state diagram, guys. So this is called as a transition state machine or state diagram. Okay, yes. And we are also having a transition table. So if you represent this exact diagram in terms of table, so how we represent is, so we are having how many states, guys? So we are having Q0, Q1 and Q2. So these are the three different states, and what are our symbols A and B. So if Q0 with A, I will go to Q2. If Q0 with B, I will go to Q1. Q1 with A, I will go to Q1. Q1 with B, I will go to Q1. Q2 with A, I will go to Q2. Q2 with B, I will go to Q2. So this is nothing but our transition table. Got it? Yes. So this is the symbol for start. This is the final state. These are the transactions. Got it? Yes. Okay. Yes. So I think I have already represented in this way, right? Yes. So this is the representation for that, right? Yes. Okay. And to be clear, I told you that we'll be discussing about regular languages later on, but I just want to give you an overview, guys. So in simple words, a particular language is said to be regular if we can convert that regular language into a finite automata, guys. So for this language, I was able to convert it into finite automata, right? Hence, this particular thing is a regular language. Got it? Yes. So now I hope everyone got a clear idea with respect to all the basic terminologies and this example, right? Yes. So in the next lecture, we are going to start drawing the diagrams, guys. I will give you the question and you need to draw it. Okay. Yes. So please bring a book at least or some piece of paper so that you can practice along with me, guys. And I am being 100% clear here. If you only practice, only then you can score in this subject, guys. I'm being 100% clear here, guys. If you are not interested in practicing, I think this subject might not be a good subject for you. Okay. Yes. Okay. So in the next lecture, let us start some examples, and in the next lecture, we will be mainly concentrating on starting with the symbols, ending with the symbols, and substrings. So I think these are the three things which we'll be discussing in our next lecture, and the next lecture will be 5th lecture, and up to 10th lecture, I think so, we'll be discussing about this concept only. Okay, so up to 8th lecture, we'll be drawing the diagrams in this way, and in the 9th lecture, we'll be discussing about a complement of DFA, guys. Okay, so means around there are 4 lectures just drawing the diagrams, and there are around 30 to 40 diagrams here. Okay, yes, we'll be drawing each and every one, and I will not show in the book, guys. I'm going to draw it on a piece of paper along with you because I also want to practice this subject. Okay, yes, and this is my favorite subject. Okay, yes, so let us meet in the next lecture and discuss about these examples. Okay, yes, so let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.